You are welcome once again. This is Solomon at Soul for Math, and this is a continuation of our episode about quadratic expressions. We want to look at a few more examples before we may proceed from where we stopped last time. So we want to expand some of these expressions. Simplify. Roman numeral 1, if you have 3x minus a 4 into 3x plus a 4. Alright, we looked at how we can handle this. We looked at some identities and we said if you'll have something like this, then this looks like a difference of two squares. So what we do, let me first expand this. Normally we would say this is the same as 3x into, like the first number expands or multiplies with the second bracket, then minus 4, the second number also multiplies with the second bracket, and then we expand, open the brackets. Here it will be 3x times 3x, that is 9x squared, then 3x times a 4 to be plus 12x, minus a 4 times a 3, that is 12x, then negative 4 times a 4, we get minus 16. So you can clearly see that these ones will cancel out, so we remain with 9x squared minus 16. So if we don't go this way, we looked at an identity and we said if these numbers are the same, we have 3x, we have 4, 3x, 4, but the difference in these brackets, the factors, is the sign in the middle. Here we have a negative, here we have a positive. Then we can handle that as a difference of two squares. We consider it as a difference of two squares. So it means we would say 3x minus 4 into 3x plus 4 equals to the difference of two squares, meaning we square this minus a square of this. It's a difference, that's why we have a minus here. So this one, when we simplify it, will be 9x squared minus 16, the same as this. Alright, let's look at another example here. If we have 5x minus 3 squared, we also looked at an identity about this, that if you have a plus b squared, then this one is the same as a squared plus 2ab plus b squared. Then if it is a minus, if you have a minus here, okay, then we would have a minus here. So in this case we have a minus, so meaning our 5x minus 3 squared is equal to 5x squared minus 3 times 5x, sorry, there is a 2, let me put a 2 here, times a 2, this 2 here, the minus is here because we have a minus here, then plus, what was our b? Our b is a 3 squared, and on simplifying we end up with 25x squared. Then this is 3 times 5, that is a 15, times a 2, 30, so we have minus 30x plus 9. Okay, looking at the last example about that. we have x plus y into y minus x. This is a difference of two squares. Someone would want to maybe make these brackets have like start with a y, because one is starting with y, this one is starting with x. But a good thing we have a plus here. We can always swap these numbers to appear like y plus x into y minus x, and this one is equal to a difference of two squares. We just square this and then minus a square of that. As simple as that. So let's move on to factorization. We want to see how we can factorize numbers. If you're given numbers like 2 and 3, then their product is equal to 6. So we say that these two numbers are factors of 6. So any two numbers or any numbers that you multiply to give you some bigger number, we call them factors of that number. So like here 2 and 3 are factors of 6. So meaning when you multiply 2 times 3, it gives us 6. So when we take it to algebra, or in terms of algebraic expressions where we use letters, in algebra the letters represent the numbers. For example, if you have a times b, we know it is equal to ab. Okay, so we say that a and b are factors of ab. So in order to factorize an algebraic expression, what we do, we find the factors of the expression that is given. That is what you need. For example, if you want to find to factorize this, you need to find the factors of AB. That's why we say factorization. You factorize, find the factors. If you were to factorize 6, find the factors of 6, then we get 2 times 3. So you will have factorized here. Alright, let's look at examples. If you have something like x squared plus 2x, okay, what we do, find factors of each of the terms here. So for example, I would write x squared as x times x. Those are the factors of x squared. What about 2x? I would write it as 2 times x. So you see, of the factors of x squared and the factors of 2x, which ones are common? You see x is here, x is also here, so we can take it out. When we take it out, what do we remain with here? We remain with x. What about here? We remain with a2. So this is a factorized statement. So you realize that factorization is the opposite, or it's the reverse of expansion. Let's look at another example. Number 2. Let's try to expand x plus 2 into x plus 4. This one, using the identities we looked at, this would be equal to x squared plus, this would be 6x and plus 8. Okay, so before we would ask questions like expand, and when you expand you get this. Now we are saying factorize this. So to factorize this, they want you to go back to this to get the factors of this expression. So the factors of this expression are these. So how do we get those factors? That's what we want to know. In a case where you have something like x plus a into x plus b, this will be equal to x squared plus, this would be a plus b x plus ab. So if you're asked to expand, remember to factorize, we are moving from this side to this side. So it means they're actually telling you to find the values of a and b. If you have a and b, okay, then remember we are moving from the right to the left. If you have a plus b, if you have a and b, then you just come and fill it here, okay? Because this side we have x plus a into x plus b. If I have my a, I have my b, I just put them here, and then this is what they want. This is a factorized statement. Maybe we look at an example. One, factorize, or everything you're going to do is to factorize. Let me write here, factorize number 1, x squared plus 7x plus 12. This is equal to, let's compare it with the other expression that we've written in the previous example. X squared plus a plus bx plus ab. Okay, if we can find the values of a and b, and if you can find the values of a and b, then we can be able to, remember we said this one was x plus a into x plus b. So if you have a and b, then you can just substitute them here and you have your answer of the factorized statement here. So let's find a and b. If you are to compare, it means that when we compare this and this, find a and b so that a plus b is equal to 7, and then ab should be equal to 12. Like find two numbers so that when you add them, they give you this number, the coefficient of x, with its sign. If it's a negative, then you also get the numbers that give you that answer, that value. Then the same numbers when multiplied should give us a 12. So which two numbers do we multiply to give us 12? And when we add them, they give us 7. So those numbers are, we have a 3 and a 4. You see, when you add 3 plus 4, it's a 7. When you multiply 3 times 4, you get 12. Okay, so it means that my x squared plus 7x plus 12 equals to x plus 3 into x plus 4. Want to look at a more systematic way of factorizing? Let's look at an example. Factorize x squared minus 6x plus 8. So what we do, find two numbers so that when you add them, like the sum should be equal to -6. Like I said before, the sum, when you're getting the sum, take everything, even with the sign, even if it is a product. So the product should be 8. So which two numbers are those? So that when you add them, you get -6, but when you multiply them, you get 8. So have a -2 and a -4. Okay, you just look out, just consider numbers, take two numbers, add them. When you succeed in getting the sum, check if when you multiply them, you get the product. So these are the numbers. So like we have -2 and -4. So what we do here, we expand this. So like this, the x squared minus 6x plus 8 would be equal to x squared. Now where there is -6, where there is this, we put in this. So we take the -2 with x, give it x, then take also the -4 with x, then leave the constant there. Okay, because after all, -2x minus 4x, it gives us the -6x. That's why we wanted to get the sum that is equal to -6, so that when we substitute this, they will replace this. Now after that, we do group. You group any two numbers. I can take this and this, this and this. Then you factorize out, you do some factorization here. Look out for the common terms, common factors. Here we have x squared, this is 2x. You can see that we have x as common. What remains? Remain with x minus 2. What about here? Another thing, we are focusing at getting two brackets here. There's one bracket here, and then this term should also have a bracket. Now, what we have in the brackets should be the same. So what I'll do here, I'll take out a -2. Sorry, -4. When I take out a -4, because there is a negative here. So when I take out a -4, this will remain x because it was -4. Now I've taken out -4, it remains x. What about here? This one remains a -2. Remember, it was positive, so that when we expand back, it must take us back here. -4 times -2 should give us 8. Because it was positive, that's why I've made this a negative, so that when I expand, it must give me this. Okay, remember, our expansion should not change the meaning of the statements. So we can factorize again. If you look at this bracket and this, they are common. Okay, like they are common factors in this term and this term. So we can take that common factor out. When I take it out, what do I remain with here? I remain with x. What do I remain with here? I remain with -4. And that is the factorized statement. Let's look at one more example or two. Factorize x squared minus x minus 30. We say look for two numbers which give you a product. Remember, there's a one here, silent one here. They should give us a sum of -1 and a product of -30. Yes, I said if there is a negative, then the product or sum should come with its sign. So that's why here even the product has a negative. So which numbers are those? I can see when you multiply 5 times 6, they give me 30. Yes, but when I add, they give me 11. Yeah. Okay, but we have a sum as -1 and then a product of -30. So how can we make this -30 so that even the sum is negative? So since 6 is bigger, I'll give it a negative. Remember, when you multiply a positive and a negative, you end up with a negative. So I'm sure I'll end up with a -30. Even when I'd put the negative on 5 and if 6 remained positive, it would give me -30. But since I wanted a -1, I had to put the negative on the bigger number. So meaning we have two numbers here. We have 5 and -6. So we expand like before. We said x squared minus x minus 30. We can write it as x squared plus 5x. We replace this negative x with these other terms, minus 6x, because we are sure that these, when we get 5x minus 6x, they give us -x. So after that, we group. I can take this and this, then this and this. After grouping, we factorize out what is common here. I think it is x. When it is x, what remains here remain with x. What about here? We remain with the 5. So here, what is common? I think it's a -6. We have 6 here, we have 6 here. And there's a negative. Negative is also common. You take it out. When I take it out, what remains here? It is x. What about here? Since the negative is out, divide 30 by 6, remain with 5. Just make sure when you try to expand, it can take you back to this. Okay, because it should be two-way. Okay, it should take you back to this, and when you go back, it should also come back to this. So, and also make sure that these brackets are the same, but don't force them. They should come automatically, systematically. So after that, we realize that these brackets are the same, are common. So we take it out as a common factor. What remains here remain with x, and here remain with a 6. I'll finish this with one more example. If you have x squared plus 2x minus 15, what are the two numbers that give us a sum of 2 and a product of 15? We have 3 and 5, but we give this a minus. Okay, so when we expand, our x squared plus 2x minus 15 will be equal to x squared minus, just substitute the 2x with this, minus 3x plus 5x minus 15. Where am I getting the negative here? It is from this. So we group. I can take this and this, this and this, so that when I factorize out x here, what remains? I have x minus 3. Do the same here. Factorize out here. What is common? 5. Here I will not take out a minus because I've seen it. It is here. Okay. So it means when I take out just a 5, this will remain x, and I'm sure this will remain minus 3, which is equal to x minus 3, because it is common, it is here, it is also here, remaining with x plus 5. Yes, thank you for watching. Don't forget to subscribe and to share and to comment. In case you have any questions, you can put them in the comment section. See you.